Assalamualaikum warahmatullahi wabarakatuh. Okay, today I gonna start the presentation of our power system analysis project presentation. Okay, first group members is Muhammad Fukraiman bin Zulkarnain, and second is Ahmad Mira Ashraf. Third is Muhammad Ihsan, and fourth is Khairuddin. So our project title is power flow analysis with photovoltaic distributed generation. So we are from section 3 group 5. Okay, our lecturer's name is Dr. Ahmad Fateh bin Muhammad Noor. Okay, so we go to the chapter 1. Okay, first, number 1 is the project background. The power flow analysis is an important tool in the study of power systems. The success of the power system depends on knowing the repercussions of connecting new generators, interconnections, adding new loads or distribution system, and connecting new transmission lines before they are established. There are numerous methods for analyzing power flow in the power system network. Newton-Raphson is often used for power flow analysis due to its dependability. Two modulating methodologies for power flow analysis are Gauss-Seidel and fast decoupled. The Newton-Raphson approach is widely used in power flow analysis because it has the advantage of analyzing large volumes of data for systems with numerous branches and buses while still producing an accurate result. Next, we go to the problem statement. Renewable energy is seen as a major technology for reducing energy-related environment challenge, particularly CO2 emissions, by governments all over the world. Most developing countries lack fossil fuel and natural gas resources. However, traditional energy sources have a number of drawbacks, including the fact that they are not renewable and will eventually run out. Renewable energy sources are considered good energy source because optimal use of this source reduces environmental impact, produce low secondary waste, and is economically viable in the present and the future. There are numerous examples of renewable energy sources, including sun, wind, hydro, biomass, and many others. Solar energy is divided into two types, heat and light. Sunlight and heat are transformed and absorbed in a number of ways by the environment. Biomass and wind energy are two examples of renewable energy flows produced by these chains. By replacing renewable energy sources for traditional energy sources, renewable energy technologies have enormous potential to reduce greenhouse gas emissions and global warming. Next, our project objective first is to investigate the degree to which the power flow system changes in response to change in load demand. Next is to determine the value of incremental load required for the generator to supply the maximum and suitable level of power. Third one is investigate the role and efficiency of PVDG in resolving and lowering the power flow problem caused by excessive load demand. Okay, the fourth one to simulate a power flow study of an IEE standard power system with various load levels in order to obtain the largest number of load incremental values before the system collapse. Okay, the last one is to alleviate the problem, determine the size and position of PV of photovoltaic distributed generation (PVDG). Okay, for the scope of this project, the project scope is to create a MATLAB code editor capable of simulating IEE 5 bus interaction load flow analysis. Aside from that, the PQ bus that will be modified by 100% from the original data till the system collapse will be bus 4. The actual and reactive power of the load are the variables that will be controlled in the MATLAB Newton-Raphson function. Besides that, PVDG will be implemented to prevent the power grid from collapsing. The true power of the generation is the variable that will be utilized to install the PVDG in MATLAB Newton-Raphson algorithm. Furthermore, the PVDG installation is applied with a power weightage of 500 megawatt. Okay, that's all from me. I pass this presentation to my group members.
Assalamualaikum warahmatullahi wabarakatuh. Thank you to Ihsan. So now, my name is Muhammad Zulkarnain with number matric AE200012. So I would like to continue the presentation. I will present about the literature review. First, according to D.K.20 research, the Gauss seidel method and the Newton-Raphson method are used to solve power flow problems on the IEE 5-bus system. The variables are expressed in rectangular coordinate, linear convergent characteristic, computation time per iteration is less. And slack bus selection is critical for the Gauss seidel method, whereas variables are expressed in polar coordinates. Quadratic convergence characteristic, computation time per iteration is more, and slack bus selection is arbitrary for the Newton-Raphson method. After dalam GTK Tanti comparing the two methods, he discovered that the Gauss seidel method has simple calculation and is simple to implement. But the number of iterations increases as the number of buses increases. Whereas the Newton-Raphson method has complex calculation, but the number of iterations is low when the number of buses is high. Next, Sanjeev Hazarika, an assistant professor in the electrical engineering department at GIMT in Hazara, India, investigated the power flow analysis of the IEE 5-bus system. This research is used the Newton-Raphson method to compute the power flow in an IEE 5-bus system, as well as the real and reactive power losses. Variation in real power loss and reactive power loss are reduced as the real power demand increases. Last, for the literature review, according to Mir Hadi Athari, Zifang Wang, and Said Hamid Ilyas, research on photovoltaic distributed generation influences on a local distributed network. Time series analysis of photovoltaic distributed generation impacts on a local distributed network. According to a time series analysis, commercial buses with distributed photovoltaic distribute generation, which is PVDG, have the lowest network energy loss and the highest penetration ratios. Due to greater alignment of commercial loads profile with solar irradiation during the day, it has been discovered that dispersed installation for commercial buses may be performed with optimum energy loss reduction. When the penetration ratio exceeds a certain level, reverse power flow and voltage quality must be addressed. As a result, the best PVDG placement suggests a maximum penetration level to minimize difficulties while reducing network power loss and minimizing voltage deviation. So that's all from me. Now I will pass to the other presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Khairuddin Bisani. So today I will explain about chapter 3, which is methodology. Okay, firstly, I will explain about Fila table. In Fila table, we have 4 things, which is facts, idea, learning issues, and resource. In fact, we have 4 facts. Okay, firstly, to make a study regarding power flow analysis of IAE power system. Second, to investigate the degree to which the power flow system change in response to change in load demand. Next, investigate the role and efficiency of PVDG in resolving and lowering the power flow problem caused by excessive load demand. Okay, lastly, to alleviate the problem, determine the size and position of PV of photovoltaic distribution generation. Okay, next slide. I will explain about Newton-Raphson method. Newton-Raphson method is an open method of root finding, which means that instead of narrowing down to the initial guess, it only requires a single initial estimate to achieve the solution. To get closer to the root, the Newton-Raphson method uses the slope of the function at the sum point. We can determine the location where y equal to mx plus c meets the x-axis using the equation of line y equal to mx 0 plus c, in the hopes that the original function will meet the x-axis somewhere nearby. If we repeat the same method for the value of x, we can get back to the original root. Next slide. This is the flowchart how the iteration method works. Okay, so this is the circuit diagram that we use for our project. In this circuit diagram, we have 5 bus. This is also circuit diagram, but this is the circuit diagram after PVGD installed. Okay, lastly, this is the coding that we use for MATLAB. So that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name Ahmad Anwar Ashraf Osman. Okay, for my part, I will explain about the result and the discussion. Okay, for our group project, my group choose the power analysis of IEEE 5 bus system. So, this is the bus data for IEEE bus system, 5 bus system. Okay, so I put this data to the MATLAB. This is the data for IEE by system in MATLAB, and this part is the line data for IEEE bus system, 5 bus system. Okay, I will run this data in MATLAB, and then we get the load flow analysis for the data. Okay, so this is the data for power flow solution by Newton-Raphson method. This is the data about the bus system, and this is the data for line flow and losses. So the total loss is 4.587 and negative 17.421. Okay, this is the circuit diagram of IE fiber system. This is the standard circuit put the before we put the PV panel. Okay, this is the circuit diagram when we put the PV panel as buses 4, and this is the result when we run the circuit in a Simulink, and then we get the result for the buses when we put the PV panel in buses 4. The result for real power flow, reactive power flow, current flow, real power losses, and reactive power losses. Okay. Next, I will explain about the discussion. For the discussion, we are using MATLAB. Simulink to develop the solar power producing system for our home. The component needed for a solar power leveling. So if we take a solar panel or a photovoltaic panel, we are obtaining direct energy from this solar panel. The DC output will be obtained if the solar panel inputs irradiance and temperature. Unfortunately, we are bringing solar energy to our home, but our home require 240 volts and AC supply rate. Our solar panel are receiving a DC supply rate in this scenario. The power electronic device or inverter is required to convert DC supply rate to AC supply rate. In other case, the inverter does little more than convert the DC supply rate to a pulsating AC. That is, we are experiencing pulsing issue but not pure AC. Even though pure AC is necessary at home, we all need to connect a passive filter to convert this pulsating AC to pure AC. Another issue is that the output DC of a solar panel is dependent on temperature and watering rate. Therefore, the temperature is in the atmosphere is not constant. It varies from down to evening. In the afternoon, we only obtain maximum power, whereas in the morning, evening, or cloudy days, we only get low power. We don't receive the exact result in such case. Okay, so to overcome the problem, we are connecting the boost converter after the solar panel and connecting the step-up transformers. So that's all from me for the discussion. Thank you.
Assalamualaikum. Okay, lastly, I would like to continue by the conclusion. For 5.1 summary of project, from this project, we're able to investigate the degree to which the power flow system changes in response to changes in load demand. Besides, we're able to determine the value of incremental required for the generator to supply a maximum and suitable level of power. Then we're able to investigate the role and efficiency of PVDG of resolving and lowering the power flow problem caused by excessive load demand. Furthermore, we stimulate the power flow of SAIDI and IEEE standard power system with various load levels in order to obtain the largest number of load incremental values before the system collapse. Moreover, we are able to alleviate the problem, determine the size and position of PV of photovoltaic distributed generation, which is PVDG. Lastly, we are also able to construct and run the coding using suitable software, which is MATLAB. Then for 5.2 references, we look for 6 references, which is in each reference we put in here. We look for the information in all of these reference to complete our project. So for 5.3 appendices, for minutes of meeting 1, we use the Google Meet platform as the meeting platform. For minute of meeting 2, we use the WhatsApp as the meeting platform. For minutes of meeting 3, we use Google Meet also as the meeting platform. And lastly, for minutes of meeting 4, we also use Google Meet as the meeting platform. So that's all from me. That's all from us. Thank you for listening.